Good morning, everyone, and welcome to week 6 of Foundations of Algorithms. Just making sure, if you haven't seen it already, assignment 1 is now out, so please take a look at the LMS or at the class website if you haven't already, and check out project 1 that's due in roughly 2 weeks now. We do, as always, have the First Year Center open every day for you, so go get help, get started early, because it will save you a lot of stress and possibly panic later. So what we're going to be talking about today is a little bit more about software engineering. Now, this is distinct from coding. Coding is just the ability to write the particular program that you want. But software engineering is a bit more of a professional discipline. It's the art of taking the coding that you do and actually putting it to use for the purpose of engineering larger projects or working in a bigger company with multiple people. And while what we teach you in Foundations of Computing won't take you all the way to becoming a software engineer, at least we can maybe give you a little bit of insight as to some of the skills that you'll need to develop over time. So we did talk a little bit last week about debugging and about software testing, and these are also going to be themes for today. So the first thing we need to discuss is a way to break up our code. If we're working on a large project, it's no longer going to be appropriate for us just to have one giant file that has all the different pieces of code for the entire project. Like, imagine that you were writing code to control a space station. Like, the space station has been in the news recently with all kinds of problems. Imagine you're writing the code for the space station. Now, there are lots of different things that you might want to do. You can imagine that there is a landing module connected to a lander on the space station. There are the airlocks to control. There is the rotational system and the thrusters, all different pieces. And if you have one giant code file, not only will it be difficult to read, but it will be difficult to maintain and difficult to debug when things start to go wrong. You won't be able to navigate easily. Now, of course, this is not because the computer itself actually cares in the way that you break up your code. It'll run the code no matter how you've written it, as long as it's correct. However, by breaking it up into different pieces, we actually allow the humans who interact with your code to handle it in an easier manner. So Python does provide, like every other programming language, support for breaking up your code into these different modules. And in fact, in Python, they're explicitly called modules. But we're first-year computing students, and so it might seem like a bit much of a tall ask for us to write the entire code for the space station. Maybe we can chew off like a tiny little piece. And so instead of writing all the code that we need to run something from scratch, we are instead going to use what are called libraries. And this is just a nice way of describing code, a module that someone else has written. So a library might have useful functionality like containing functions that tell the computer how to compute sine, cosine, tangent, logarithms, all of that kind of thing. When you approach writing your program for the first time, you don't want to have to re-implement a function that computes the sine of a number for you. Much better if one of the experts has done that ahead of time, and then you can import their code into your project. And indeed, this is the word that Python is going to use to enable us to access a library that someone else has written, the import statement. So let's take a look at an example of actually doing this in our own code. And I'm going to start by importing some mathematical functions. So let me switch over here. All right, and so I could start off by writing a function area of circle. Now, let's get one of these, and it was Angela over there, right? Was it Angela? Yes. Have you been at the front before? Do I need to give it to someone else? I don't remember whether you've been on live yet or not. Okay, so help me out here, Angela. What do I need to compute area of a circle? The radius seems like a good start. And then what will be the contents of my function? How do we compute the area of a circle?
Pi squared,
So pi by
Radius. Well, and then square.
Well, I could do that, or I could just do radius by radius. Okay, are we done?
We have to define the name of like the output, like the thing. So probably we'll have like, I don't know, area, like a new variable called area. And
Okay.
I don't know.
Are we done?
But the pi is defined though.
Okay, pi is not defined, and what else are we missing from our function?
Well, it depends on the accuracy you want to get. If you just want like a general, like you can just.
So I'll help you out. I'll write a doc string.
Oh.
What am I missing?
Um,
What does the doc string say? First word in the doc string.
the input, like you have to say what the input of
It's highlighted.
returns
So what am I missing at the end of my function?
or return area.
Yeah, I'm just missing something that returns area. But as Angela pointed out, we haven't put in pi into our function. So maybe I'll put in pi. Okay, let's try that. And I will open a terminal for us. There we go, there's my terminal. And I'll go into the directory in which I've put my file, and I've called it src, which is short for source code. And I will run python examplemath.py. Okay, still doesn't do anything. What's my problem?
You have to call it.
I have to call it, okay. So now we'll do area of circle of radius 1. What should the area be?
3.
Is the area of a circle of radius 1 3? Okay, let's run it. Okay, still doesn't do anything. What have I done with the result of area of circle over here? Have I done anything?
No, well, it will return it, but then I don't know.
Let's print it. I think that seems reasonable. Okay, so print area of circle. Okay, 3. And someone shout out, is the area of a circle of radius 1 3? Anyone else? No? Over there with the NASA. You know how to make a space station. What's the area of a circle of radius 1? Pi. Right, so 3 is a little far off. Well, I guess I could do 3.14159. Someone help me out. What are the 2, 6, 5, 5? 897. Okay, so essentially we've started to run out of digits. Our class is getting a little confused. And so this probably is not the right way of computing the area of a circle. We need something better than trying to memorize pi. So instead, let's use the import command, and we're going to import a library, import a module called math. Okay? And now we have access to a whole bunch of functions and constants and variables that someone ahead of time has written for us. So instead of trying to remember the digits of pi ourselves here, we could do math has an element inside of it called pi. If I mouse over in Visual Studio Code, I can see it's a floating point number that's going to contain the value of pi. So now if I run Python example math, there I get the value of pi. But because I've built a function, I can easily compute other areas as well. So that's working well. So that is my plain import statement. But that's not necessarily going to give us enough flexibility. So in Python, we're going to want to be able to do things like import everything inside a library so that we don't have to type math.py, math.sine, math.log every time we want to do something. So for this, we've got import star. Now let me very quickly uncapitalize that because Python won't be happy. There we go. import star. And what import star is going to do is it will take everything inside the module and put it as if you'd written it inside your main file. Now, this has some benefits, but it might have some drawbacks as well. Do you want to pass the microphone forward? What was your name again?
Anne.
Anne. Why might I not want to import star with a really big library?
Probably there's going to be like too much data.
Too much in what way? You're on the right track.
Like too much, like all the math data in the library. Like
So one thing is it might slow our program down. If we've got a lot of stuff that we're pulling in, it's going to take a little while to copy all of that into the part of the program that contains everything else. So maybe that's a reason. Another reason is I don't know everything inside the math library. I don't know all the different names of the different functions in there. And if I've started calling writing my own functions, and I've suddenly brought in all of this stuff from the math library, Angbo was giving me eyes. He was telling me, you know, I'm going to have written a function with the same name as something inside the math library, and I'm not even going to know that I've created this conflict because I've just included everything without actually knowing what I'm including. So we could try this in our code and just to, from math, import everything. And now we can see that we've now got a squiggly line underneath math because we no longer have imported math itself. We've imported everything inside math. So now I should just be able to use pi. But the Visual Studio Code has given me a squiggly line and a squiggly orange line and a squiggly red line. And if I put my mouse over, it says wildcard import from a library not allowed. Now, it doesn't mean that Python doesn't allow it. What it means is that if you do this, it's going to start confusing our analysis tools and going to start making our lives difficult. So while you can do this, it's not necessarily recommended as a software engineering practice. And so this is, again, one of the differences between just writing code and trying to engineer a larger software system. But here we've also seen some new syntax, the from statement that we can combine with import. So let's say we know we want to import pi, but we don't want to import everything else inside the math library. Well, what we can do is we can tell Python explicitly which things we want to import. So I'm going to tell it I want to import pi and nothing else, and now my squiggly lines have disappeared. But I could add a comma and tell it that I also want to include the log function, for example. And now it's gone gray because I haven't used it anywhere, so that's letting me know that, well, you've imported something that you haven't used, but if I use it now, print log of 2.71, for example, and I've almost gotten close to E, which would be, if I put in E correctly, then I'd get 1 as the result of log, because this is log to the base E, the natural log. And of course, there are a lot of other functions inside the math library. In fact, there are a whole lot of other libraries as well, and you can start to look around to see which libraries are built into Python and that contain all sorts of useful functionality. Very often when you start writing a piece of code, it'll be a piece of code that someone else has probably written before, and so you might want to check if there's a library either built into Python or even, and we'll get to this soon, that's not built into Python but that you can get from the internet that has the kind of code that you're writing now. And this is a legitimate part of programming, and in fact an important part of programming is minimizing the amount of reuse, of rebuilding things from scratch you do, the reinventing the wheel, by finding libraries that other people have done to complete similar tasks. Now give me a second because my slideshow isn't behaving properly. One moment, everyone. There we go. So one other nice syntactic thing to know is you can also rename things using the import statement. So if I decide that I really want to use the word pi, I want to use the word pi somewhere in my code, but I still want to use pi from the math library, but I don't want to use the same name as the math library called pi, I'm going to call it something else instead. So what I could do is I could now import pi as cake. And now pi no longer exists in my code, but cake does. And let's print out what cake is. Let's do area of circle 1 again. Now cake is what pi was before. So all I've done is I've told Python, when you import pi, instead of calling it pi inside the main body of code, now you're going to use the same variable that you had before, you're just going to relabel it. And in this case, I've relabeled it as cake. Now, I'm providing for your edification a list of some of the libraries that you might start to think about as an example of places that you might look for functionality. So if you want to copy or move a file or interact with the operating system, libraries that you might use are OS and pathlib. Pathlib is particularly helpful for navigating around the file system on the computer. There's the time library, and I haven't even put a description there because it's somewhat self-evident. Random, which allows you to get random numbers from the operating system. And then one other that we'll look at in a moment, which is the collections library, which has other useful types of collections beyond dictionaries, sets, and tuples that we've seen already. There are some more advanced types of collections and more interesting things you might want to do. So let's take a look now at the collections library and see where this might be useful. You already have an idea of the power of some of the data types we've already got. Why would we need anything more? So I'll give you an example over here. Here is some code I wrote earlier, and I'll give you a couple of seconds, and I want someone to volunteer and tell me what this bit of code actually does. It counts digits in a string, but what's the problem with my code? What don't I like about this? Okay, if there's no digit, it will return 1. It shouldn't do that. Alishka, do you have an idea? Why am I sad? It's not going to error out. Think software engineering. Any ideas? Just throw something out there. There should be comments. Okay, that's a really good point. It would be easier rather than having you sit there trying to figure it out if there were comments. There's something a bit annoying about the code. Alishka, let's pass the microphone forward so we can at least hear her. And do you want to? And it was Jitsu.
I'm not 100%, but it might just be a bit clunky because for every single digit, you have to check it's in the counter.
You got it. Alishka's got it. She said, you know, we've got this bit of code. Every time I run this, I'm checking to see if the counter dictionary already has the digit in it. And this is really a pain. So let's try and work around it. Now, by default in Python, there isn't anything that allows us to set a default value for a given item in a dictionary. But we only have so many digits, 0 to 9, at least in base 10. And we know that by default, all of those should be set to 0. If we've never seen a digit before, that digit should be 0. So I'm going to now use the collections library. And I've said the word default a few times. And this is because I'm going to use a dictionary that allows us to set the default value for something we've never seen before. So let's say we are looking in the dictionary for how many times we've seen the digit 8 before, and we've never seen it before. What should the dictionary default to? And Alishka, you've got the microphone.
1.
Should it default to 1?
There's no 8s, it should be 0.
It should default to 0, and then the first time we access it, we should be able to increase it by 1. And the second time we see it, we should also be able to increment it by 1, and this allows us to preserve the same behavior no matter if we've seen it before or not, by having a default value of 0 for the dictionary. So now what I could do is, instead of making counter a dictionary, I could make it a default dic, this special type from collections. And I am going to, let's see, new dictionary initialized from the mapping objects key value pairs. And so we can read through the description here if we want some help. And so I am going to create a new default dictionary of integer type. And now, whenever I access a value that wasn't in the dictionary, it will default to 0. So what should I do with my code now?
Get rid of the if-else statement and keep counter digit plus equals 1.
Okay, so let's follow that suggestion. And now, just to keep my code neat and tidy, what should I do with this line?
Indentation.
Indentation. Okay, so let's print count digits and see what happens. Actually, I don't even need to put it as a string, because we can see here that we're automatically converting that type to a string within our function. So now let's run Python default dict example. And when I print it out, I can see it's printing out this strange syntax to indicate that I'm not just printing out a dictionary, I'm printing out a default dict. And then we can see there were 2 2s in the number I wrote in, there were 3 3s, there were 3 8s, 2 9s, and 2 1s, etc. Now, this looks a little ugly, and so I'm going to use another library to print it out in a bit of a nicer way. And this is the pretty printing library, or pprint for short. So I know, just from having looked it up online earlier, that there is such a library that exists, and inside it, there is a function called pprint. And all that does, if I change print to pprint, it's going to print it out in a nice way. So now you can see that it's separated things out onto different lines, and that's just a more pleasant way of looking at it. There's no other functionality change there, but you might want to use this when working with dictionaries just so you get a clearer display. Now, we're stuck at the point where Python only has so many of these useful libraries, but there are a lot of interesting things we might want to do. And one of these things that we talked about last week is test our code. Now, I've already seen one way of testing code in Python, and this was by the assert statement. And this would, when we ran our code, if an assertion was false, the program would just crash. So let's try that first, and then we'll think about some of the reasons why this might not be ideal. So let's go back to example math. And instead of pie is cake, I'm going to go with what I originally started with, where I couldn't remember digits of pi, and so I just put in 3. And now I'm going to write a test. So def test area of circle. And I will get it to check that pi. That's what it should be, assuming we've done it correctly. And now I'm going to run the test. So Python example math. Okay, it's thrown an error, which is good because we know that there was something wrong with our area of circle function. We weren't using pi there. Now we do that. No error. So that's good, but this isn't ideal from an engineering perspective. Alishka, can I grab the mic? Thank you. And we'll go to our NASA friend over here. Now, what was your name?
Jordan.
Jordan. Okay, so from an engineering perspective, why might this be not ideal for testing a large system?
You have to put in the known values anyway.
So you have to put in the known values anyway, but that's going to be one of the challenges of testing in general, is that to run a test, you generally need to know what the outcome of the test should be. So that's not ideal, but maybe something that we'll have to figure out a different way to deal with. What's a problem of using the assert statement in this way?
It's a little bit limited to exactly what you're testing.
It's a bit limited, and also notice in my code I had to explicitly run this test area of circle, and that's going to start cluttering up my code if I've got these assert statements everywhere and then I have to run all these different test things. It's not a particularly productive way of building a large suite of tests. For something like our space station, we're going to want hundreds, thousands of tests, and that's going to start cluttering up our code very quickly. So instead, we are going to use a library, and this library is called PyTest. But unfortunately, it doesn't come built into Python. Let's check online. Let's see if I can do this quickly. If I put PyTest into Google, you can see this is not on the official Python website. This looks a little bit different. But let's go to their Get Started page and see what happens. Okay, run the following command in your command line. Pip install PyTest. So this takes us to talking a little bit about package management. Now, lots of different programming languages have this concept of a repository of different libraries that other people have made and put publicly online in what we call open source. So the source code for what other people have written is available to anyone. And you want an easy way to be able to download those. So this is where we use what's called a package manager. And for Python, the most common package manager, indeed the one that comes built into Python, is called pip. And we can use pip to download libraries that other people have submitted to the library repository maintained by the Python Foundation, the people who kind of manage the Python ecosystem and the Python language. So if we go back to the PyTest website, we can see the command it's giving us to run is pip install, and this is a command that you'll use many times over your programming careers, PyTest. And what this will do is it will go to the Python repository online. You can only run this command if you have access to the internet. It will get a copy of PyTest and put it on your computer. And then whenever you want to use PyTest, you can just import it into your own project. Now, one of the other cool things about this library in particular is it's not just a Python library. Also, when you install it from pip, it gives you a new command that you can run on your terminal. And this is the PyTest command. So let's check this out a little bit. So I have some tests that I've written earlier, and we're going to build up to the point where any of you can write tests like this. So I'm going to go back to my week 6a directory, and I'm going to use the ls command to display everything in that directory. And I can see that I have a folder called tests where I put all my tests, and a folder called source where I put all my source code. And now I've set this up earlier just so it would work properly, and so I'm going to run this command pytest. And I can see I'm now getting all these assertion errors just like before, and it's told me which tests have failed. We're not going to look in great detail at this second, but now I've separated out my tests from my source code, which is going to be very useful, and we will return to this example very soon and actually start to go through it one by one. But for now, we've now enabled for ourselves a new way of building software. And this is called test-driven development. There we go, test-driven development. And the basic idea here is hopefully you have some idea of the functionality that your program should embody. You have some idea of at least one case that you know already of what should work and what shouldn't work. So the way that test-driven development works is as follows. Write a test for your program. Doesn't matter if you haven't written the program yet. Just write the test. Now run all the tests using a command like pytest. It should fail. You haven't written any code yet. But now go back and write some code to make that test case pass. Now, don't just make it code that repeats exactly what the test wants to see. Start writing your program. But write your program in a way that you know you can get that first test to pass. Maybe there are some bits of it that you haven't finished implementing, but we'll leave those to later tests. Now, when you finish that, run your test suite again. Right now, our test suite only has one test in it, but we've just written code that's designed to pass that test. So great, we've done that one. Now go back to the start again. Write a new test for some additional functionality or another case that you know your program is meant to embody. When that fails, go back, fix your code, write new code if you need to, and then run all the tests again. Not just the first test or your new test, run all of them to make sure that the new code that you've written hasn't accidentally broken something. And this is indeed something that's very important in a lot of software development, is making sure that every time you add a change to your code, that you haven't accidentally broken the things before. So as you move on in your programming careers, you'll start to see different ways of ensuring that this happens. Indeed, in large companies like Meta, every time you add a piece of code to the code that Meta is actually using, it runs a whole bunch of tests before even letting your code into that main body of code that everyone's contributing to. If your code fails the test, it's going to reject it. So what kinds of tests should we actually write? Well, there are a few different cases that we might want to look at. So let's first talk about edge cases. Now, edge cases are very common in life, and these are instances where something that works ordinarily, you would expect to have a little more trouble because of something at the boundary of the kind of process that you're doing. Here's an example. Let's try writing some code to check if a year is a leap year. Now, do you want to pass the microphone one back? What was your name?
Pin.
Pin? Okay. What is some code to check if a year is a leap year? Let's say I give you an integer, year, and you want to check if it's a leap year.
Well, you probably check if you put it, let's say, your number of days, and if it's like 366.
Say again?
If the integer in terms of days, if it's equal to 366, return.
So if we just have the year, what do we know about leap years? All years that are leap years end in... How often are leap years?
I'm not actually quite sure.
Anyone? How often are leap years?
4 years?
Every 4 years. So how can we check if a year is a fourth year? So let's start with the year 0. The year 0 was a leap year. Year 4 would then be?
Would be year 3 if you start.
It'd be year 3. So let's start at year 1. Year 1, leap year. Year 4, leap year. Next leap year. If they're every 4 years?
Year 6? No, 7.
If it's 4 and we need to wait another 4 years for a leap year?
7?
If year 4 was a leap year?
Yep.
Well, it's 4 years later, 8. Okay, so what's an easy way for us to check if a year is a leap year or not? If it's 4, 8, 12, 16?
Every 4, probably.
And how do I calculate that? If I give you a number, let's say n, and you want to know if it's a leap year, how do you calculate that? If it's divisible by 4. Okay, so let's try that out. So if the year is divisible by 4, return true. The year is a leap year. Now, what's the problem with this? Someone else. What am I missing? What do we know about leap years? Someone who knows a lot about the calendar. Elizabeth. Let's get the microphone. Well, pass that microphone down and I'll give you another one in the meantime. Let's see. You were on the right track. There we go. Sorry. Isn't there the...
Like some bizarre rule where it would be like every 4th year, but if it's like divisible by like 200 or 400, like it's a millennium, that it's not.
Really close. There we go. So we have this weird, what we call an edge case. It's an exception to the normal behavior of the leap year, that if the year is divisible by 100 and divisible by 400, then the year is not a leap year. I think I've gotten that right. There might still be a mistake there. I'll have to double check that one. But there is a bizarre rule either way around leap years, and so we need to add this extra condition. And so if we were doing test-driven development, we could check ahead of time which years are leap years and then start putting in cases. Well, we know the year 2000 was or wasn't a leap year. So let's get a test case from the internet. Year 2000, leap year. Okay, was 2000 a leap year or not? The year 2000 was a leap year, although 1900 was not. So except for end of century years, which must be divisible by 400. So now we have additional test cases that we can now put into our code to try and determine is it behaving correctly. So just having that one test case of divisible by 4 wouldn't have been quite enough. So this gives us a hint of the kinds of things that we might want to test. We'll want to test typical cases. We're going to want to test cases on the boundaries. So for example, if we know there's a maximum length of something, we might want to test that maximum length. We're going to want to test things which are infrequent, but that we still expect to occur once in a while. We're going to want to test null values or empty values, things which we think someone malicious might put in. So invalid inputs, things which might break our code, combinations of all of the above, and then combinations of edge cases. So for example, if it's a century and it's a 400 year, divisible by 400, that's an example of not just an edge case, but a corner case, because it's a combination of two different conditions. So one way that we're going to reason about our test cases is we're not going to test every possible input to a program, because there are just too many possible inputs. So if we're testing something with the integers, we might want to test a small integer and a larger integer and a couple of integers in the middle, but there's a problem with these ones in particular in my test cases, assuming that we haven't tested any of the stuff with the ... dots. Well, what's the problem with my test cases here?
You won't get any leap years at, like, if it's just 1551, 201.
Yes, so you have to design your test cases intelligently. And all of these are odd. So even if I had more test cases like these, I still wouldn't actually catch the behavior that I'm trying to get. So now we're going to move to another example beyond our leap year for the last 10 minutes, and we'll use this as an example of test-driven development. Let me just set it up. So what we're going to want to write, as we see here in this example, is some code to test whether something is or isn't a palindrome. Now, remind me, what is a palindrome?
It's a word that's spelt the same forwards and backwards.
Word that's spelled the same forwards and backwards. So what's an example of a palindrome?
Kayak.
Kayak? Yeah, that's a palindrome. Good example. Okay. So now I'm in my week 06A directory, and I'm going to run my PyTest command in a moment, and I'll just show you some of the tests that I've written. So I have written test function should accept palindromic words. So if I input noon, is palindrome should return true. And so this library that I've included, this PyTest library, gives me the ability to write code in a particular way that makes it easier for me to write tests. So I've done self.assertTrue, and we'll learn a little bit more about this syntax later on in semester, but for the time being, this is just a demonstration of test-driven development as a concept. I'm not actually expecting you to be able to write this own code and structure it yourself. So it's more an illustration of test-driven development. Okay, so let's write our first test, and I'm going to comment out everything else. So test function should accept palindromic words. So when I input noon, I should get true. So now let's run my PyTest command. And it's complaining because I don't actually have anything at all inside its palindrome, so I need to have something. Okay. Failed. Test function should accept palindromic words. None is not true. So the reason it's complaining is because I haven't actually returned anything. So let's imagine I return false for everything. That'll change the error message there. So false is not true, and it's testing the word noon, and so if I'd written this correctly, this should be returning true. So let's write some basic code to test whether something is a palindrome. And here is some code I prepared earlier. Okay, so as Elizabeth said, if something is a palindrome, then if I reverse it, it should be the same backwards as it is forwards. And remember, our syntax for iterating backwards through something is this : and then -1. So now what do I expect to see?
That test should pass.
That test should pass, okay. Okay, one test passed, great. Are we done?
No.
Why not?
Well, you have a bunch of other tests that you might want to look at.
Okay, so you haven't told us which test, but I'll give you a freebie on that one. So let's now, test function should ignore case. So now I have a new test case here. Noon with a capital N should still be a palindrome. Okay, let's run my PyTest. Uh-oh. Test function should ignore case. False is not true. Uh-oh. Okay, what can I do? Anyone got an idea? Not Elizabeth. It's someone new who hasn't said anything yet today. Marka. Okay, convert the string into either uppercase or lowercase before I actually test for equality. So what I could do is something like that. And what should I do on the other side? Now let's run our tests. We've made our change. Okay, now 2 tests pass. Great. Okay, let's go back to our test. Okay, test function should ignore trailing spaces. Okay, input string equals noon with a space, but that really should still be a palindrome. It should just ignore like if a user has accidentally typed too many spaces. Let's run PyTest again. Uh-oh, it failed. But you know, this is actually kind of what we're trying to do here. We're trying to make our function more robust by slowly adding in extra test cases for some of the expected behavior and then modifying our code each time. So Elizabeth, I'm going to steal a microphone back from you. And we're going to take it to someone random who's going to help us with the next little bit. You're sitting on the edge over here. What's your name?
Anayat, that's A-N-A-H-I-T.
Anayat.
Yeah.
Awesome. Okay, so how do I make this test case pass? Function should ignore trailing space.
Well, I'm not sure about it.
Do you know of a function that allows us to get rid of spaces at the end of a string?
Yeah.
Well, what's that function? Starts with an S? ST?
It was split by, it was strip.
Strip?
Yeah, strip.
Okay, so how can I change my code so that this test case now passes, so that it ignores any trailing spaces?
We'll add a function triple there, maybe dot.
So if I add strip over here, then it'll convert it to lowercase, it'll remove all the spaces from the end, and then it will reverse it. Do I need to do it on the other side of this equality as well?
No, I get you.
Why not? So let's give it a try. Oh, still fails. So if we want now, we could do this by hand and try and look at what it's doing. So let's imagine we have noon with a space. So first it converts it on the right-hand side to lower, and then removes the space, and then reverses it. So that would still be noon. But on the left-hand side, it would only have converted it to lowercase, and then it would still have the space there. So they're not going to be equal, which means on the other side, we're also going to need to do the strip. So let's try that. Dot strip. Now I'm going to run PyTest again. Oh, there we go. Okay, 3 test cases passed, and we're almost at the end there. Okay, test function should ignore extra spaces in text. Okay, so now we're starting to get a little more complicated. Anyone have an idea of how I might be able to deal with these cases where there are lots of extra spaces randomly put in my string? Anyone know of a function that we can perform on strings that might help us with this? Yeah, I've forgotten your name again, but Max. Yeah, dot remove. Okay, we could use dot remove, and the other one? Also starts with an R, dot replace. So I'll use dot replace in this example. And so I'm going to replace all the spaces with just an empty string. I will do this on the other side as well. We've learned our lesson about how that works. Now I'm going to run PyTest again. Oh, where have I made a mistake? Replace, sorry. There we go. See, test-driven development does work. Okay, PyTest. Okay, 4 test cases passed. We're almost there. And then the last one we are actually not going to do. That was going to handle Unicode characters. So if you want to handle foreign languages, you know what? I will put that one there just to show us that even after all this work on our test palindrome, we're still not able to handle Unicode, which is for characters in foreign languages. And sometimes those characters actually take up 2 different slots inside our string. So we'll leave that test case failing for the moment. But Max, why am I unhappy? Other than that test case. What's wrong with my code? Okay, next to Max. What was your name? Ethan. Why am I unhappy? So that's a really good point. I'm now doing all of these like lower, strip, and replace twice. And even more than that, my code is just butt ugly, right? I've got too much going on this one line, so it makes a lot more sense to start breaking this up. So I could do something like test string equals input string dot lower dot strip dot replace with all of that, and then I could do test string, and then let's run PyTest again because I modified my code. So if I modified my code, I have to run my test suite, and we should expect to see 4 passed, and then that 1 failed that I'm leaving as some work for later. And so now we know that even my changes that I've just put in haven't made my code worse. And while getting PyTest set up and writing the tests exactly the way that I've done them might take a little more than just the next week for you because it is some more advanced functionality, this idea and this notion is really powerful. And even just using the assert statements, you're already capable of doing this kind of software development. So with that, thank you very much. I don't think I'm lecturing for you for a few weeks. You're going to have Kat for the rest of this week and then Giuseppe for a few weeks, but you will no doubt see me as I will be at the front of the class helping to get us all set up for the start of every week. So with that, thank you very much, and I will see you soon. And now we've got a few minutes break while Kat gets set up.
Okay, so let's probably get started. So today we'll be discussing mid-semester test that is coming the next Friday, not this Friday, but the next Friday. But before we start, I thought like I would share some kind of pleasant surprise for me. I was not expecting that. It's sort of like maybe motivation for you, how you apply this knowledge in real life. So I'm doing some collaboration with the School of Psychological Sciences, looking at how concepts in psychology change over time, how like trauma changes like from the 1970s to nowadays, how addiction changed since then, how mental health concepts such as depression, autism changing over time. So they have the hypothesis that these concepts, they become less severe and they applied to a broader range of events. So like if the 1960s trauma was like physical injury, nowadays like there might be just emotional trauma. Like my son says, like homework is trauma for him. So, and they came up with this hypothesis, and now the question is how you measure this. So we collected lots of text data, and then we developed a model of lexical semantic change, how meanings of words change, and how to measure that. Doing programming, of course. So, and now I wake up today to the news that this was discussed in this like a super popular Instagram guy whose name is Etymology Nerd, who has 1 million followers, who's discussing this work. This is like something really surprising to me, something like we did this like academic work, and now he mentioned this to this 1 million audience worldwide. So I never heard of him before, but this coming from my PhD students, they just following him probably. I'm not sure how many of you know this guy. No, no one? Oh, some of you know. So yeah, you can see our work discussed there on Instagram. So, okay. So now let's go back to the lecture content. So mid-semester test is coming, so it's your very light version of the final exam. It's only worth 10% of your final mark, so you consider this as just a practice before the final. So, and the plan for today is to discuss some mid-semester test logistics and the expectations from you, and then we go through some typical questions from the mid-semester test. So as I mentioned, the test is coming next Friday. So this Friday we'll have advanced lecture about object-oriented programming, and the next Friday we'll have the mid-semester test. So it will be 6th of September. So it will be during the usual lecture slot, and it's roughly, it's 40 minutes in duration. And before that, you will receive a list of your seat assignment. So we will be using this theater, Wilson Hall, and the other building on the other part of the campus. So, and in terms of the coverage of content, so everything up to the end of week 5 will be included in the test in terms of the lectures, and up to week 6 in tutorials, and the worksheets 0 to 10. So, this will be just pen and paper, no laptops, nothing like that, just pen and paper in your brain. So it's a closed book exam, so you're not allowed to use any extra material. You're also not allowed to use any electronic devices. You need to turn off your mobile phones, smartwatches, etc. So, and this is just typical exam conditions and expectations. So, to see this mid-semester test, you need to get to this assigned location. So again, the list will be released on 3rd of September. On the LMS, you will see your particular location and the seat number. So you need to make sure you bring your student card and something you use to writing, either pencil or pen, ideally a pen. So, but make sure you do not forget the student card, okay? Because you'll have to put your student number on the MST sheets, and we will also check that that's you, actually. So, in terms of academic adjustment plans, if you have anything, you need to submit it to this URL. So there is a special form for submission. So if you are still waiting for AAP, make sure you contact us, lecturers, in advance. So what else? So if you feel like you got sick on the mid-semester test, on the day of the mid-semester test, make sure you visit GP and get the medical form and then mail it to us, okay? And if there is any emergency, you just contact us, the lecturers, either Shannon or Giuseppe or myself. So in terms of non-emergencies, if you have other commitments, such as the job commitment or maybe some other subject at the same time slot, it's your responsibility to manage this. So, and of course, this mid-semester test is mandatory, so you need to attend it. And you need to make sure that you talk to the other subject coordinator if you have a clash. So the expectations now. Is it clear? So it's 40 minutes long, and we will cover the lecture material until the end of week 5. Your seat assignment will be released on September 3rd, okay? And it's pen and paper only, and student card, okay? It's closed book exam. Is it clear? And it's 10% of your final mark. It's a preparation for the final exam. So, in terms of the questions and the topic coverage, so if you want to get just a pass mark, so our expectations from you would be the following. So you need to know the basic data types, such as integers, floats, strings, booleans, and type conversion between them. You also need to know expressions and arithmetic operators, logical and comparison operators. List, tuples, slicing, iteration, the input function, print function, formatting, and f-strings, the condition statements, and the 2 types of loops, for and while, built-in functions such as length, range, enumerate, sorted, sum, max, etc. And you also need to know how to define a function and return a value from that function. This is your pass mark. Now, if you want to have a good mark on top of that, we also expect you to know sets, dictionaries, and their operators and method, parameters and arguments, their default values, methods on strings, and again, methods on lists, tuples, sets, and dictionaries, and also the difference between mutability and immutability. What is mutable data type, what is immutable data type. And in order to get the great mark, you need to know these advanced topics on functions. And note that the test will not include anything with respect to this Blockly worksheet 0. There will be no Blockly. It will not ask you to kind of draw these blocks on the paper. So now let's go through the questions. Let's do some practice. So we'll have 3 types of questions. So the very first questions, there will be 4 of them. So they just ask you to evaluate some Python expression. And you evaluate, and of course, you also need to specify the data type. So here is an example. You'll be provided with such an expression. So it's 20 floor division 6 plus 14 modulus 6. You'll need just to put the answer. So if it's a decimal or float, if it's a float number, so you need to put the decimal point, of course. That's how you indicate the data type. If you think the result will be a string, you need to put the quotes. Okay? Make sure you specify the data type this way. So let's go through some practice. What will be the result of this expression? So it basically evaluates your knowledge of the priority of the operations, right? So we need to remember that the division and the modular, they have higher priority than addition, right? So you start with this leftmost, so it's 20 floor division 6. What will be first? What will be the result? And then you need to also specify the data type. So what will be the result? 20 floor division 6. So it will be 3, right? And since it's floor division, so the floor division gives us just which data type? Integer. So you just put 3, so you have it in mind. Of course, it's not the final result. Then you go to the next operation, which is modular. What will be here? So it's 2, so 3 plus 2, the result will be 5. So, and basically what you need to do, you need to put this 5 as like this, okay? No decimal points, right? If you put the decimal points, we interpret that as a float, and you'll get deducted, okay? Let me also just copy this thing, and we just check that we are all correct here. This is 5, indeed, okay? So when you put 5 like that, you don't have to specify this data type explicitly by saying, okay, this is 5, it's an integer. As soon as you just put 5 without quote marks and without decimal points, we just interpret this as an integer number. So the next one. What will be the result of this? So there is a string, and then we perform what sort of operation? It's called slicing, right? And we start at index 2, and we finish at which index? So it's 5, right? 6 is non-inclusive. So what will be the result here? Yeah, it will be MPEL. So it's 0, 1, 2. So we start with M, and then we go up to 5 inclusive. So it's 3, 4, 5. So it will be MPEL. So let me again copy this to Python interpreter. So you all trust me that it's correct. Okay, this is MPEL. And in this case, you need to put either single quotes or double quotes, because the result is string. You need to specify that this is string. This is how you specify that this is a string. Okay, the next one. So we do the type conversion, and what happens? So it will be 4. So we take the whole part from 4.6. So this is just 4, okay? Again, no decimal points, because this is just the integer number. So let's do a few more. So we have, the next one is 15 as string times 3. So what does it mean? So when we apply this multiplication operator, it means we are repeating the same string this number of times. So it will be, the result will be a string, and it will be 15, 15, 15. I got some extra space, sorry. So it will be 15, 15, 15. And do not forget to put the quotes, okay? Otherwise, your answer will be incorrect. So each time you answer correctly, you get 2 marks, okay? So the next one. So we have the function range. We specify 3 parameters, and we make a list out of this. What will be the result? Yeah, so we say that we start at the element 2, right? We go up to 8 non-inclusive, and every time we increment by 3. So it's 2, 5, and then 8 is not included, right? So it's just 2 and 5, and it will be the list. So 2 and 5. And in order to indicate that this is a list, you need to put the square brackets, right? That's how you signify a list. Okay, the next one. So we have a dictionary where the keys are those integer numbers and the values are strings. And then we call the function sorted. What will be the result? Yeah, so we basically apply this only on the keys, and we sort the keys. So the keys are 1, 3, 2, so we sort them, and what data type do we get from this? Yeah, this is a list, of course. So we get the keys, we sort them, and we get this sorted list. 1, 2, 3. Okay? The next one, what do we have here? Who can explain me? Anyone? Yes? This one, this one, yeah. So we have this two sets, right? So the sets are specified by this particular type of brackets. And we deduct one set from the other set. So what will be the result? Who can tell me? So the result will be, which data type it will be first? Let's ask this question. This will be a set, right? And what will be the elements of that set? Which one? 3, 5, and 6, right? So now let's also check this in Python interpreter. So it's indeed 3, 5, 6. Of course, because sets are not, they do not have any particular order, if you answer 6, 3, 5, it will also be considered correct, okay? There is no predefined order in sets. Okay, so the next one. So you probably started so you can finish this one. So we have string as our string, right? And then we perform something. So what will be the result of this? So we start at index -3. So it's -1, -2, -3, right? And what do we return? IRT, right. So we have the increment of -1, and we go until -5, right? So it's -3, -4, -5. And -6, again, it's non-included. Sorry. Extra spaces here. Okay? Any questions about this part? Let's do the final one. So we have a dictionary, we take the values, and then we take set out of this. So it will be 1 and 3, right? So we take the values are the second numbers, 1, 3, 3, and we call set, so it means we only retrieve the unique elements. So let me just copy this. Come on. No. That's not what I wanted. Okay, so it's just a set of two elements, 1 and 3. Again, you can put 3 and 1. That's fine. The order doesn't matter. So is it clear? The first question is relatively straightforward and simple, right? So you'll have 4 sub-questions of this type. So, and each correct answer gives you 2 marks. The next one, so we'll have 3 types of questions. So the second one is you need to write an expression. So for instance, suppose that text is a Python string, give a single Python assignment statement that creates a new version of text in which all of the alphabetic characters are converted to lowercase and in which all leading and trailing blank characters have been removed. So the crucial part here is that it should be a single assignment statement. Because sometimes students put these multiple assignments, it's not correct. You can still get some partial marks, but not the full marks. So in this question, you need to come up with the solution that is a single assignment expression. So, and you take this text, and then you need to get the required answer. So what do we need to do? So let me just, as an example, assign something to this test. Of course, you are not supposed to do this in your answer, so just to illustrate. So suppose this is our text. So, and our task is to give a single Python assignment statement that creates a new version of text in which all the alphabetic characters are converted into lowercase and this trailing and leading blank characters have been removed. What do I need to put? We just discussed this with Shannon, by the way. Sorry, what? Dot, so text, dot, so we need to recall the methods for strings, right? Dot. So we need to call dot lower, so we transform this into lowercase, and now we need to remove this leading and trailing blank characters, and for that we use the method strip, right? It will remove from both sides. And we can actually call, because lower already returns as a new string, the modified one, we can call the strip on top of that. So that's our solution. Because we only need to remove this, like the blank characters at the start and at the end, not within, okay? So, and you can, of course, first call strip and then call lower. In this case, the order doesn't matter. So both will be considered as correct solutions. So this is your solution. So this is the single. So again, you need to put this result. So it should be assignment. You need to assign it to something. Suppose you need to assign it to out. So this will be your solution. A single assignment statement. Is this clear? So, and for each of these solutions, correct solutions, you'll get 3 marks, okay? So there will be 4 questions of this type. So, and the final question, yes? In most cases, we'll say like how to name the variable, but it doesn't really matter if you just came up with the different name and the solution is correct, so you'll not be penalized for just coming up with different name. Yeah?
Do we have to put the variable, or can we just do text.lower?
So it should be assignment, so you need to put the variable on the left-hand side part, yes. So, and the most expensive question is question C. So it will give you 20 marks. It requires you to write a function following some description of a particular problem. Typically, it's quite straightforward problem, and it requires you to write 10 to 12 lines of code. So we'll not require some sophisticated functions such as lambda functions. So it will be based on whatever we already discussed. So, and before we turn to the practice MST discussion, so I'll just also finalize a little bit with some tactics for the mid-semester test and for the exam as well. So if you are not sure about whether your solution is correct or not, you can still put it. You can get some partial marks at least. So have a go. The second principle is keep it simple. It's a very general principle that is also applied in the other like science disciplines. So if you have a choice between obvious and obscure, you should always choose the obvious one. So, and look back. So some partial answers might be in other questions. You can get some extra hints from the other questions. And the general principle also, do not panic, stay calm. Like if you're not sure about one particular question, you go to the next one and then get back to that first one. So, and of course you know more than you think you know, so, and this is just like a mid-semester test, it's 10% of your final. Just treat it as a preparation for the final exam. Okay, so, of course you need to start preparing now. We already released some practice mid-semester tests and the tests from the previous years. So try doing this, go also through workshop exercises, go through the lecture materials, read the lecture slides, and discuss. For now, you can discuss with your peers. If something is not clear, you can ask also us for the help. So that's pretty much it. And now we turn to the actual one of the mid-semester test versions from the last year. So this is what you will get. You will get this 4-page, yes? No, no. So we do not expect you to write the comments. If you like, you can provide some comments, but this is not expected. So you will have this 2 sheets, 4 pages. So, and this is the title page that will explain the instructions. So you'll have this 40 minutes, authorized materials none. So you only have your brain, pen, and the student card. And this is a closed book exam. Oh, sorry, not exam yet, it's a mid-semester test. So your electronic devices must be switched off for the all 40 minutes. And in total, you can get 40 marks from this. And again, it will be just 10% of your final mark. So, and let's go through this question. So that's where you will put your student number. Please do not forget, otherwise we will not be able to identify you. And then when you finish, you need to show your student card, and we just check that it's actually you. So this is question 1. As I mentioned, you just need to evaluate an expression. If you think there is an error, you just put this error in the text box. So you'll have the text box. That's where you need to put the answer. So let's also go through this question. So what will be the result of this expression? So we have 16 floor division 4, then exponentiated to 2 plus 1. So what will be evaluated first? Which operator has the highest priority here? Yeah, exponentiation. So we have 4 times 4, right? So it will be 16. So then 16, then floor division 16. What will be the result? Yeah, it's 1. And then what do? We add 1. So let's go here. So it will be, the result will be 2. Okay? And this is clear. If you just put 2, it's clear that it's integer, right? The next one. So we have this string, and then we perform slicing, and then we also multiply by 3. So what will be the result? Anyone? Me, yeah, that's right. So we extract the first 2 characters from meow and then repeat it 3 times. So it will be me. And make sure you put either single or double quotes. Me. The next one. So we take a string and then make a tuple out of the string, and then we add another tuple. What will be the result? So, can you repeat? So what data type will be? there. What will be the resulting data type? So it will be tuple, right? So we just created a tuple. So there is a tuple here, then we add an extra tuple, and we result with the tuple, of course. So it will be A, B, B, A, C, D, a single tuple. Is this clear? The next one. So we take a list, then we extract some elements from that list and take a sum over that elements, right? So which elements will we extract? So we start at position 1. So it's 0, 1, so 3, then 6, and then 8, right? So we increment by 2. So it's 3, 6, 8, and then we take the sum of this. What will be the sum? So this, so we did not specify the end, so we will have like this, the final one included. So if we remove the sum, so the final 8 will be included. Okay. Again, each such sub-question is 2 marks worth. Now let's go to the next question. So you'll have 4 questions. Each question is 3 marks, where you need to write a single Python assignment expression. So let's start with this question 2. So I'll give you some time to think about, and then someone can come here and type the answer. So suppose that ABBA is a non-empty list of characters. Give a single Python statement that assigns true to out. So this is our out variable on the left-hand side. If all the characters in ABBA are the different ones. Or it assigns false if not. So it's non-empty list of characters. Let me just give you an example. So it can be A, B, B, A actually. So this is just single characters. So in this case, it should return false, right? We have this list that contains repeated characters. So what do I need to put here? Does anyone want to try? Give it a try? Come here, just come here and type. Let me increase this. Okay. So you need to put this result into out. So you need to take this variable ABBA, okay? So that's correct. So the len, and then you need to use this variable called ABBA. One thing that you need to correct, so this difference will give you a number, but you need to get the Boolean value. You need to get the Boolean. You need to compare the results of 2. You need to get either true or false. So let me just give a hint a little bit. So you take the lengths. This is the correct logic. You take the lengths of the initial list, and then you create a set out of this list, meaning that you extract the unique elements from that. And then you need to compare, right? The lengths of the initial list and the lengths of this result of extracting unique elements out of this. And in order to get true or false, we need just to compare, right? We need to check whether these 2 lengths are the same. So, and if I put here out, of course, it will be false in this case, right? Is this clear? So you need to make sure you return the correct data type as well. So true or false means you need to perform some comparison, right? Yes?
I'm not quite sure, but is that we can like generally use lens?
Sorry?
We just like says equal to ABBA equal to set ABBA. Is that possibly working?
So what's your proposed solution again? I'm not sure I'm following.
Alt equal to ABBA, double equal to set ABBA. That you compare like has been changed.
If you just check whether ABBA as a variable equals to the set of, but that will be different data types. You can, they are not really comparable. Okay, so let's go to the next one. Suppose that top is a tuple of integers whose length is an even number, so it means it's either 2, 4, or 8. Give a single Python statement that assigns to is lucky as true if the sum of the numbers in the first half is the same as the sum of the numbers in the second half. And otherwise, it should assign false. So you see that our output variable will be called isLucky, and we assume there is a tuple called top, and we need to check that the sum of the first half of this tuple is the same as the second half. So let me just copy this initialization. Again, in this particular question, you should assume that this tuple is already provided. You do not need to put this extra assignment statement. It's just for illustrative purposes here. So you need to put something. So your output would be isLucky, and we need to put something out after that. Anyone has a solution? You can welcome. Okay, so why do you need to transform this into integer?
In the case where the user inputs maybe just a string.
No, here, yeah, another thing, you just need to assume that, you see, like it's tuple of integers. So you should already assume it's an integer. So you don't really need to perform any extra conversion here. So this is like we try to be as precise as possible. So you don't need to have this extra conversion. So, and can you explain the logic here?
So some will add all the first three on the index from start to the fourth.
So you need to go to the middle. So you need to extract, in this particular case, 3, 5, 1.
My bad. In this case, it will be, this is assuming.
Yeah, we of course start with the index 0, right? So it's 0, 1, 2. So the middle point will be up to this. In this particular case, it will be up to this third element, right? So it's 0, 1, and 2. So 3, 5, 1. And the second one extracts this, everything starting at position 3. Okay? One thing that you can fix here, this is something that is called like hard coding. So ideally, you would like your code to work on any, like a tuple of any lengths. assuming that it has this even number of elements. So instead of just hard coding, so ideally, please do not hard code. So you need to generalize. You need to take the length, right? You need to take the length of the tuple, floor division 2, floor division. Because if you just divide by 2, you'll get float, right? And you cannot use the float number in your slicing. So, and here we just start with the same. So it's length of the tuple, floor division 2. Okay. So does it work? So is lucky. In this case, yeah, it's true. So it's 3 plus 5 plus 1 will be the same as 3 plus 3 plus 3. So again, this is your solution. Please do not hard code. If you put hard code, like this, the exact number, so we will deduct for that. So you need to make a code that generalizes to the scenario that is described here. So this is a particular purpose where you put this like even numbers, so you can make this assumption that it will work in these cases. Okay, thank you. All right. The next one, oops. So question number 4. So suppose that Teams is a Python dictionary in which each key is a string denoting a team's name and the value is an integer denoting their score, assuming all scores are different. Give a single Python statement that assigns to top scores a list with the 3 highest scores in decreasing order. And we again make assumption that the dictionary contains at least 3 entries. So let me just give you an example of that dictionary. So we have Teams, and we have, what do we have? Key is a string denoting team's name. So suppose we have some team A, and their score is, say, 12, and then team B, it has the score of 4, team C, that has the score of 9, and team D, that has the score of 20. So what do we need to return? We need to return, let me just put this as teams, sorry. So we need to return something that we'll put in top scores. It's a list with the 3 highest scores in decreasing order. So we need to take these 3 highest scores, right? So in our case, we'll return 20, then 12, then 9. What will be the solution? So we need to put this into top scores. And it should be a list. Okay? Think a little bit. And then someone might come here and give it. Ah, someone already done this. Okay. Come here. Yeah. Okay, run it. Ah, there's something, probably something missing. Ah, sorry, yeah, that's my bad. I missed the underscore, I didn't see it. So top scores, let me just print it. Now, yeah, one more thing missing, yeah. You need to take the top 3. That's right, well done. Okay, so the next one. So question 5, suppose that str1 is a non-empty string of alphabetic words separated by dashes. Give a single Python statement that assigns to len str the number of words in str. If str is, say, it is hot, separated by these dashes, your statement, the assignment should return 3. Okay? We identify the words by these dashes. So let me just initialize just an example for str, which is hot. And then we need to put the result into len str. Again, I'm missing the underscore. So len str, so what do we need to put there? Anyone? Sorry? Oh, the question, sorry, yes. Yes? Yep. So let's check len str. Oops, sorry. So it's 3. So yeah, that's correct. So what we've done, so we split this string into substrings, right, using this dash as a separator. So the result of this method will be a list of strings, right? And then we ask how long is this list? So by using the function len. Well done. Now, the final question, the most expensive one. So it's 20 marks. So I'll give you some time to think about this. So here you'll need to write a function. So in this case, the function should be called preprocess, and it takes 2 values, str1, str2. So we assume that they are both non-empty Python strings. And it should return a list of words from str1 that do not appear in str2. So both strings should be first lowercase. Words can be identified by just spaces, very simple assumption. And the word order in the final list should be the same as in str1, the initial word order. So, and you will be also provided with some sample execution sequences. So for instance, if we have str1 as in when he inked the sink, and this str2 is a cat set in the shelf, so the function should return this when he inked and sink. Okay? So I'll give you some time to think about this, and then someone probably wants to volunteer to write this code. So let me just, where should I put it? Let's go to Python tutor, maybe. Let's go to Python tutor. So we need to define this function. So it's called preprocess, str1, str2, and then at the end it should return something. We can call this out. And then we can also, so this is not required, so you can just, so the only thing that is required is the function itself. You don't need to provide this different calls of the function. And, okay. Let me just turn back to the description. So we need to lowercase the strings, and then we need to identify the words. Okay, anyone wants to volunteer? Someone got the solution? Hooray, we have a volunteer. So let me just get you to, is it Python tutor fine with you?
Yeah. I'm planning on making it 2 sets and then minus it.
So why you call it the method strip? So you can actually, like in this case, it's not described. Like you can assume that the strings do not have any like blank characters at the start and at the end, or you're splitting them.
I'm splitting.
Splitting. So then, yeah, split. Yeah, that's the right, because I wasn't following why you need a strip. So then you create 2 sets, these unique words from both strings, and then you also make sure you need to lowercase. There's another thing that you need to lowercase. You can call it before splitting.
Yeah.
Or, yeah, you can just put it here. Yeah, lower. And the second one is lower.
Sets.
So you take the difference between the 2 sets. You look at the words that appear in one but not the other. But then you also need to make sure there's like another thing that the word order in the final list. So the result will be a list. The list that contains these words from str1 that do not appear in str2. So, and it should follow this the initial order. So you okay. So you took the difference between the sets, and then.
Then I'm gonna try to sort it. And then I cannot sort it. I can transfer it back to your list.
Or you can go through the first one, so you already have the list, and you just check whether this particular word in that list appears in this out. So you'll have, this is your set, but you need to get the initial list.
How can I do that?
So you need to go through these elements of this str1. And then what do you need to do? You need to check whether these elements are found over here in the set.
How am I supposed to do that?
Okay, so let's ask others. Anyone? We're almost there, but yeah, we need to get an extra fix. Anyone? So we took the difference. So let me just print what we have so far, but we also need to make sure that we follow the order of these words in the initial string, which is str1. So for now, actually, I don't need this. So let's just return the set for now. But that's not the solution yet. We are not there yet. So this is our result. He, when, sync, inked. So here we have, you see that we expect to have the list. Instead of he, when, sync, inked, we need to have this when, he, inked, sync, right? So we need to make sure that the elements follow the order in the initial string. How do we make sure that it's the case? Yeah, you want to fix this? Yeah?
Can't you just have a return list that you append, like 4 items in string 1? If they're not in string 2, then you can append the return list.
Yes, how you do that? Anyone? Yeah?
Well, I can't really fix it, but like you said, like a different method, I'll just like iterate through like a for loop, so that makes sure.
Yeah, this is like the most straightforward solution. You take this for loop through the initial list, right? And then check whether it appears in the set. If it appears, you add to the extra list. Or vice versa. If it doesn't appear, you remove from the initial list, depending, like, there might be multiple approaches, right, to the same problem. Here, there is no, like, a single ideal solution. There are multiple possible solutions. Some are more efficient, some are less efficient. But the idea would be, for instance, you can just, yeah, as you propose, you can go through this list. And then if item in our out, or we can either modify the same list or we can create a new list, right? Let's just make it more straightforward. So if item is in our out, we add to the new list. So we need to create this new list, result, we initialize it with empty list. So, and then we say, okay, result, then append, and the item. And then we put return result. So let's go through this very quickly. We go through this for loop. And here we are. So when he inked sync. That's one of the possible solutions. Again, you can do like the vice versa. You can just take the initial list and remove everything that is not in out. Okay? So, and see you on Friday. So on Friday, we will have advanced lecture about object-oriented paradigm. And the next Friday, we'll have the mid-semester test. Get prepared.